Instead of explaining here, let us discuss one example, then understand what it means and what is it. Let us see this. Let us see. Try to evaluate this integration. No, not very clear. The integration is you have to integrate this function sine pi z square plus cos pi z square divided by z minus 1, z minus 2 dz. Most of these problems you will also find solved in that book of pi z. Match with that also, yes, I have written shortly. Over this curve C, the curve is given by mod z equal to 3. Tell me what is the meaning of mod z equal to 3? What curve does it represent? Mod z equal to 3. Will tell Sunil. Mod z equal to 3 means what?
It represents the distance from the origin.
Rahul, tell.
So it represents the distance
Is
from
distance from
origin.
distance from origin. So distance of what from origin?
The distance of a point. Sir.
You see mod z equal to 3. Z is any complex number, mod z equal to 3. So it represents actually a curve. So what is that curve? Mod z equal to 3 means distance of any complex number is equal to 3. So which complex numbers are there whose distance from origin is 3?
Circle.
It's collection of all those complex numbers whose distance from origin is 3. Is what type of curve? Origin
Circle.
circle. It's a circle with
Radius 3 or origin 0, 0.
Radius 3 and center origin.
0, 0.
So it's a circle around origin with radius 3. So in this circle, whatever point you take, its distance from origin is 3. So whenever we write mod z equal to 3, it means we are talking about the circle with center origin and radius 3. Okay. The mod z equal to 5 will mean collection of all those complex numbers whose distance to origin is 5. So this collection will constitute a circle with radius 5, center origin, like that. So mod z equal to 3 means that circle with radius 3 and center origin. So integrate, you have to integrate along that circle, this function. So here you see these points of discontinuity are the main things considered. What are the points of discontinuity or non-differentiability or non-analyticity of this function? At which points it may not be differentiable or not analytic. That means you have to check the denominator. What are the points where the function may not be analytic? Govind?
Hello.
At which points it may not be analytic? Questions from where?
Repeat, sir.
In which points this function is not analytic? Means you have to check the denominator, where the denominator can become 0. Only at those points it can there.
In which?
Maybe some problem at all other points it is analytic. In which points the function cannot be analytic? एनालिटिक कहाँ पे नहीं होगा? Rajesh, okay, Govind is showing mic problem. Rajesh, discussed this earlier also, where it may not be analytic, upon which denominator becomes 0. So z equal to 1 and z equal to 2. These are the point of non-analyticity of this function. So that you have to consider. These points are inside the or outside this curve. Z equal to 3. This point z equal to 1 and z equal to 2 is inside this curve or outside this curve. Well,
inside the curve.
will they because radius is 3 and we can easily see that z equal to 1 is inside, z equal to 2 is also inside this curve. So this theorem can we apply here? If this theorem is applicable, then the result will be 0. Can we apply this theorem for this function? Anjali?
No, sir.
Oh, because the function is not analytic inside. You see, these points are outside that curve, then we could apply Cauchy's theorem and the result would have been directly 0 by Cauchy's theorem. Very simple. But that is not the case. These points are inside the curve, so we have to consider these singularities. When a function is not analytic at a point, it is called a singular point. So the singularities are now this curve, so they have to be taken care of. For that, what we do, we divide the integral into two parts. So we can write the same thing as this sin pi z square cos pi z square by z minus 2. Here one part, another part here. Can we write like this? If we take their sum, we get back that original function. Okay, so we have divided it into two parts. Try to understand how we divided it. Very simple. If you take their sum, you get back that original one. So let us call this part as I1 and this part as I2. Now let us solve them separately. Here, while integrating this part, we have got this result. From where did we get this result? Here we have applied this Cauchy's integral formula. Now you see how this Cauchy's integral formula is. If f of z is analytic inside and on a simple closed curve C, and A is any point inside C. F of z is analytic and inside on a simple curve C. The function is analytic and A is any point inside C. You take any point inside C, then the value of the function at this point A is given by this integral. It is by 2 pi I integration over C of fz divided by z minus a dz. Now you match with the current situation. Here we want to integrate this function. Here our f of z is whatever is in the numerator. Sin pi z square plus cos pi z square. Is this function analytic? Sin pi z square plus cos pi z square. This function analytic? We'll tell. Sunil Sharma.
Yes, sir.
Function analytic. ये फंक्शन एनालिटिक है या नहीं? sin pi z square plus cos pi z square. Is it analytic? वो जो न्यूमरेटर में जो है फंक्शन sin pi z square plus cos pi z square. मतलब डिफरेंशिएबल है कि नहीं है ये फंक्शन? साइन फंक्शन है कि नहीं डिफरेंशिएबल?
है सर, साइन फंक्शन डिफरेंशिएबल।
साइन है, कोस भी है,
यस सर।
तो ये भी है, साइन पाई जेड स्क्वायर भी है, पाई जेड स्क्वायर भी है, मतलब कोई तो डिसकंटिन्यूटी का बात है नहीं यहाँ पर,
यस।
all are continuous. So this function is continuous and differentiable everywhere. So this sum of these two functions is also differentiable. That means this function is analytic. So f of z is this, f of z is analytic, and z equal to 2 is a point inside this curve, mod z equal to 3. In that case, what is f of a? F of a is, or what is the value of this integral f z by z minus a? This z will be given by twice pi into f of a. Just you take this factor to the left hand side. So the value of this integral is given by twice pi into f of a. Here that same situation we are in. So this function is analytic inside and on this curve, and z equal to 2 is a point inside this curve. Therefore, the value of this integral will be given by twice pi into f of 2, matching with that Cauchy's integral formula f of 2. So this integration directly by Cauchy's integral formula you can write twice pi into f of 2. So f of z is this. So f of 2 will be just z will be replaced by 2. So that means sine square 4 pi plus cos 4 pi equal to 2 pi I. Did you understand, Abhijit? ये कैसे आया?
यस सर।
समझ आया सही में? You don't understand, you can ask me. We are applying Cauchy's integral formula here. This integral formula says that if f of z is analytic, and a is any point inside C, then fz by z minus a, this value of this integration is equal to twice pi I into f of a. Same situation here. This is our f of z divided by z minus a. So value of this integration will be twice pi into f of a, because this 2 is inside this curve. Okay. The next part is this I2. I2 is again same thing. Z equal to 1 is inside this curve, and this is our function f of z, sine pi z square plus cos pi z square. So the value of this integral is will be equal to twice pi into f of 1. F of 1 is means sine pi plus cos pi equal to minus twice pi I. Anjali, did you get this point?
Sir, my network was slow. It got distorted.
Okay, so try to understand what is this Cauchy's integral formula. This integral formula we are applying here. First, we have divided this integral into two parts. Then, the first part, once we have applied this Cauchy's integral formula, in the second part also we have applied Cauchy's integral formula. So the result is sum of these two. Sum means this minus of this. This is twice pi I, this integral is minus twice pi I. So this minus this gives us 4 pi I. That is the result. Next, there is another problem. You have to integrate this function e to the power 2z divided by z plus 1 to the power 4 along the curve mod z equal to 3, means the circle with radius 3 and origin as the center. Here again, the point of discontinuity or non-differentiability is z equal to -1. -1, you can see again, it is inside this circle. So Cauchy's theorem is not applicable. So maybe this integral formula will be applicable now. This f of z, we have to take f of z as e to the power 2z, which is analytic everywhere. So it is analytic inside and on this curve also. So the value of this integral is f of, so this integral formula has another part also. Here is if z minus a to the power 1 is there, then this formula, and if you have like here z minus a to the power something else more than 1, 1 to 3, here you have 4, then you have to apply this formula. This formula says that fna equal to n factorial divided by 2s pi I into integration of fz by z minus a to the power n plus 1. Here, similar situation. This function z plus 1 to the power 4 may be written as z minus minus 1 to the power 3 plus 1. Matching with the Cauchy's integral formula, you can see that this fna equal to n factorial by 2s pi I integration of f of z divided by z minus a to the power n plus 1. So since you have here 4, so 4 may be written as 3 plus 1. That is value of n is equal to 3. So f3a equal to n factorial, that is 3 factorial divided by 2s pi I into f of z divided by z minus a to the power n plus 1. Now just unit the value of this integral. So this integral equal to, by changing sides, 2s pi I divided by 3 factorial into f3z. f3z means 3 times derivative of fz. Fz is e to the power 2z. You differentiate it times, you get 8 into the power minus 2. Because our point was minus 1. Finally, we have replaced the value of z by minus 1 and we obtained this result. Similarly, another problem and many other problems are there. I think in the last part all of you did not understand properly. It's difficult to explain here because I cannot write also. So you try to read it carefully. You see, it's not difficult. It's quite easy. Initially, you will have some difficulty. When you do some example, you'll be able to understand. In case of any difficulty, you can consult with me. So your syllabus for mid-sem will be up to this only. Okay, that first unit we have discussed differential equations, and in the other unit we have discussed functions of complex variable. In that we have discussed first complex derivative, and next we have discussed complex integration. This much will be your syllabus for mid-sem. I will provide you the problem set for both the units. So in the meantime, you can solve other problems from those books which are given, one for differential equation, other for complex variables. So everything you don't need to study, only whatever is in the syllabus and whatever is taught. From the syllabus also, I did not discuss everything. From the first unit, I discussed everything. From the complex variables unit, I have discussed only complex differentiation and complex integration. That will be the contents for you mid-sem. Okay, so next week we will not take the class. If necessary, I will inform you about the class. If you have some difficulties, we can take. So you keep preparing the problem sets also you'll get within a week. Right? Take the attendance, then you can leave. Vijay Adarsh, Anjali Anko, Arnav Arnav, Vikiran, Rosnandan, Devangshi.